Hey guys, welcome back to 9.7 Products and Quotients of Complex Numbers in Polar Form. So, I'm not going to go through on the video of how we come up with the equations that we do for multiplying and dividing complex numbers in polar form, but we did cover that in class, so hopefully that was, just basically you just generalize two complex numbers in polar form, right? You have an R1 and a theta 1 and an R2 and a theta 2. You put them in complex form, and you multiply them both, and you get this big, long, nasty thing that simplifies down to something nice by using our sum and difference identities for sine and cosine. And basically, so when we do that, we end up with this thing here. So here is the important thing, right? Here's two complex numbers in polar form, right? R1 with a theta and R2 with its own theta. And when you multiply them together, what you get out is basically for your new R, you multiply the R's, and for your new theta, you add the thetas. And it looks more complicated than it is. So let's just do this example. So find the product of 3 cosine of 7 pi 6 plus I sine of 7 pi 6 times 2 cosine of 2 pi thirds plus I sine of 2 pi thirds. So then express the product in rectangular form. So what we do to find the new R, we multiply R1 and R2. So our R is going to be 3 times 2, which is 6. And then our new theta is going to be theta 1 plus theta 2, so 7 pi 6 plus 2 pi thirds. 2 pi thirds. And to make 2 pi thirds into 6 over 6, we have to multiply the top and bottom by 2. So that's really 7 pi 6 plus 4 pi 6, right? Because 4 over 6 simplifies to 2 over 3. So 2 pi thirds and 4 pi 6 are the same thing. Now, just like with other fractions, we can just add across the top. 7 pi plus 4 pi is 11 pi, and then over 6. All right, so now we have our R6 and our new theta, 11 pi 6, so we can put that into polar form, which is 6 times the cosine of 7 pi 6 plus I times the sine, or not 7 pi 6, sorry, I'm reading up there, of 11 pi 6 plus I times the sine of 11 pi 6. Okay. And now to put it in rectangular form, all we have to do is basically evaluate the cosine at 11 pi 6 and the sine at 11 pi 6 and distribute that 6. Now to do this without a calculator, how I think about it is 11 divided by 6 is really close to 2. And we know that all the way around is 2 pi, right? If we go all the way around, that's 2 pi. And 11 pi 6 is really close to 2 pi. Now, how close is it to 2 pi? Well, 11 pi 6 plus a single pi 6 would be all the way around, right? Because that would give me 11 pi plus 1 pi is 12 pi 6, which 12 divided by 6 is 2, or 2 pi. So this is how far away we are from 2 pi. So if I'm out here, right, I'm pi 6 away from 2 pi, which I know is 30 degrees. So that helps me evaluate cosine and sine without a calculator. And then, of course, we have to do ASTC to make sure that we get the right positive or negative. So this turns into 6, and then cosine of 11 pi 6. Well, cosine of 30 degrees is square root 3 over 2. And I know it's positive because ASTC, cosine is positive in this fourth quadrant. And then plus I sine of 11 pi 6. The sine of 30 degrees is 1/2, but it's negative because ASTC, sine is not positive in the fourth quadrant, so we're going to get minus 1/2 I. And then we just distribute that 6 6 divided by 2 is 3, so I'm going to get 3 square roots of 3 minus 6 divided by 2 is 3 minus 3i. So that's our answer there. Now we would do the same thing for dividing complex numbers, right? I'm not going to go through how we get the equation, but essentially you start out and you divide these two complex numbers, and then you multiply, you take out this r1 divided by r2, and then you multiply the bottom by its conjugate, just like when we would if we simplified complex numbers. And we use a sine squared plus cosine squared equals 1, and then a sum and difference identity to get down to this. And again, looks complicated. So this is the important thing. It looks complicated, but really all that it is you divide, to get your new r, you divide the first r by the second one, and then to get your new theta, you divide, or you subtract the second angle from the first angle, and that's all you do. So we have 12 cosine of pi fourths plus I sine of pi fourths divided by 4 of cosine of 3 pi halves plus I sine of 3 pi halves, and we want to end up expressing that in rectangular form. Well, we can do 12 divided by 4, right? To find our new r, we do our first one, 12, right, divided by our next one, 4, which is going to give us 3. And then our new theta is going to be our first term, so pi fourths minus 3 pi halves. Well, let me turn 3 pi halves into something over 4 so I can combine them. Minus, that's going to be the same thing as 6 pi over 4, right? Multiply the top and bottom by 2. And now I'm going to get negative 5 pi fourths. And again, I like to think of where that's actually at on a number line, or not a number line, sorry, on our polar axis or our x and y axis. So negative 5 fourths is a little bit more than 1, right? And we know that 180 degrees is about 1 pi, right? So we have a little bit more than 1 pi. And we know that 180 degrees is pi, right? And if I'm going negative 5 pi fourths, I'm going this way, right? I'm starting here and I'm going negative. Well, I know that, right, pi is negative 4 pi fourths, right? That's negative pi, or pi is the same thing as negative pi, right? Negative pi is right here, so is pi. And then minus another pi fourths to get minus 5 pi fourths, right? So this is just how I think about it. So I'm thinking that, we go negative pi and then we go another negative pi fourths, or 45 degrees. Right, so this is where we're at, and then we could think ASTC for later. So, here we go. Our R, so when we put this together, our new R is 3, and then we get cosine of our new angle, which is negative 5 pi fourths, plus I times the sine of negative 5 pi fourths. And then to put that in rectangular coordinates, we just need to evaluate this. So that's going to be 3 times the cosine of negative 5 pi fourths. Well, the negative 5 pi fourths is this angle that I made up here. So I know that this is pi fourths, or 45 degrees right here, right? The cosine of 45 degrees is square root 2 over 2. But ASTC, S cosine is negative here, so we have a negative there. And then plus I sine, plus, and then sine of 45 degrees is also the square root of 2 over 2. And then that I is out front, and we know sine is positive in this quadrant, so we're good to go. Again, you could also put these in your calculator, but you just have to make sure you're in the right quadrant, which is why I always advise finding the reference angle and then going from there. And then we just distribute that 3, so we get negative 3 square roots of 2 over 2 plus 3 square roots of 2 all over 2i. That would be in rectangular form, just evaluating that sine and cosine. And that's how you divide them. We had a third example here on using it for alternating current, but it's basically just a division problem. You just have to put these in polar form and then divide them. I'm not going to worry too much about that. I'm just going to focus on we learned how to multiply and divide these complex numbers. But that should wrap up 9.7.